this is the wrong tab. I'm just going to start with the very basics because I'm not going to assume too much knowledge about C++. Like some basic things like declaring a variable or making a function, okay. But we're going to start with the very basics. So you can see this example, we have some piece of code. And you have a string with a name, an integer with the age of the animal, and a float with some good boy points. But you can probably see this is quite tedious to use actually, because you have to like say you want to pass this to a function. You have to type in each argument separately. First a string, then the name, the age, and the good boy points, etc. Gets quite annoying to use. So C++ has a way to group all this data together in a new name, essentially. And that's what a class is. So you can tell the compiler to say, okay, from now on, an animal, which is a dog, for example, we can have an animal, and it looks like this. And we can tell the compiler, okay, so each animal has a name, it has an age, it has good boy points, etc. And so the way you make a class is, like, for example, like this. So you have the animal with the dog, and this is, well, not a dog, but it's an integer. Just like this one is an animal. Now this, as you can see, it gives an error. Animal is undefined because we haven't told the compiler yet what an animal is exactly. So the animal class, we can make it just like that. And now you can see it turns green, and the compiler does not complain anymore. When you create a class, you have to put a semicolon after it because C++ is weird and has weird rules. So, you have to add the semicolon there. Connection issues, that might be you, that might be me. I have no idea, actually. Yeah, okay. So you have this animal class, and it basically tells the compiler an animal, it looks like this. Right, so this code will compile, but the animal is quite empty right now. So how are we going to fix this? Well, there's two things you can add in a class. There's members and there's functions. You can, the data members, for example, the ones we've seen before in this previous example here, the name, the age, and the points. So you can add them in here. You can say string name, you can say age, and you can say like this. Yeah, okay. And we have to include string for that. Right, so this code, again, it makes an animal class, tells the compiler this is what an animal looks like, and what does an animal look like? It has a name, it has an age, and it has good boy points. And now we can use that animal. Say we want to make a dog and set its name to Barry or whatever. Then we can say my dog dot name equals Barry. So you access a value inside the class, basically, with the little dot over here. And again, we see these red squiggles because it says animal name is inaccessible. Now, this is because there's two different access modes in classes, basically. You have private and you have public. And by default, everything's private, and that means you just can only access it inside the class. Yeah, there's three, but we're only going to look at two. Yeah, protected. We're going to look at protected maybe later, but we'll start with public and private. So by default, everything's private, and that means you can't access it. But if we add public in front of it, like this, everything below the public becomes public and is visible to everything outside of the class. So if you want to make the good boy points private, oh yeah, good idea. Sure, we can try vectors next time. So you have the public members are name and age, and the private members are good boy points. So if we want to try my dog good boy points, you see that doesn't work because this one's private and these are public. Now there's another type of thing you can do with classes, and that's add functions. So let's say we want to make our animal print out its identity. We could obviously do something like this. We could say cout my dog name is age years old. You could do that, of course. But again, if you want to do that in multiple places, then you have to type out all this my dog name, my dog age functions. You have to type all of that out manually multiple times, which is quite annoying. You could say, okay, we make a function for that, print animal, and it takes an animal like that, and you just put all of that in there. Animal.name, animal.age. You could do this, of course, and that works. But the problem with that, you can print animal my dog. And that works, but there's a better way in C++, and that is to add the function print animal inside the animal class. So you just type print in here, and I did that wrong. So you just type the print function in there, and then the output. Except now we don't use the dot operator, we just use name and age. Because we are inside the class, we can just access these values as if we don't need to put my dog in front of it. We're just operating on the current dog that's this golden. So if you call this function, you do the same as with variables. You do my dog dot print. That just calls the print function for this dog. So then it will print whatever the name and the age of this dog actually is. The special thing with these member functions is they can access private members as well. So we can print in here. We can print has so many good boy points. So these can access the private members as well. So I'll just show this real quick by running it. So if we just my dog.name equals Barry, my dog.age equals 22, and we'll get rid of this. And if we just compile this, okay. Oops. Oops. Yeah, whatever. Okay, there we go. So ignore this, but you can see Barry is 22 years old and has blah blah blah. Oops. Okay. So these member functions, they can be used to change an object or print it or access the private members or something like that. Right, so let's say we have a const my dog. Then we can't do this, and you can see we can't print anymore. And it says some weird error. The object has type qualifiers that are not compatible with the member function. Object type is const animal. Because this print function assumes that our animal is modifiable, even though we haven't actually modified anything in here. And to make this function be able to be called on a const animal, we just have to add const right here. And what that does is you cannot modify these in this print function anymore, but you can call print on a const animal right now, which is quite nice. All right, so next up we have some special member functions, namely constructors and destructors. So if we want to set our dog's name and age, we have to manually type my dog dot name equals hello, my dog age equals 22 or whatever. And it's quite annoying as well. So the way we fix this is by creating a constructor. A constructor has the name of the class, and it takes how many parameters you like. You can say it takes a string for the name and an int for the age, like that. And it has no return type. That's quite important. So constructor has no return type, it has the name of the class, and just takes whatever parameters you like. So if you do this, then we have to call this constructor over here. So hello and 22. And that'll be, now we have to implement the constructor. So we just say name equals n and age equals a. So now we make a dog, and we call the constructor with hello and 22. And we just assign those values to the name and the age of the animal. Now there's another thing with this. If we just want some random dog that's not initialized, this will not work. And the way we fix this is by providing a default constructor like that. And it just, it takes no parameters. That's a special kind of constructor. And if you just call a constructor like that, then it calls a default constructor. Yeah, they are. I have to check this actually. Let me just try this. Yeah, no, they're not. Well, this one isn't, and the age just happens to be initialized to 0. But yeah, so you'll get garbage values if you try this. So you can see here, this floats just some random values. That's because we haven't given it a value. But if we would go into this default constructor and say good boy points equals 50, we're generous today, and we then compile, you can see that it is 50. So the default constructor is actually called. There's another type of special member function that's called the Destructor, and the Destructor runs when an object is destroyed. So when this dog is destroyed, which is right here, after the main function exits, the dog is destroyed, and the Destructor will be called. Now, how do we make a Destructor? You have this symbol here, and then you put the animal class name in front after that, and you have a Destructor. And we can say, in the Destructor, we can do something like goodbye dog, or whatever. And if we now run this, you can see it prints that the dog is 0 years old and has 50 goodwill points, and then it prints goodbye dog, like right here. It'll print that. So destructors are useful for like cleaning up stuff a class has used. Like you can, suppose a class allocates some huge array, you can free that array in this destructor. And another thing with constructors, a very nice thing, is you can delegate them. So what that means is, say we have this animal constructor, which has a string and an int as a name and age, but we also want to set the goodboy points to 50, like here. You could do goodboy points as 50, but that's quite annoying actually, because you have to write it twice. So what you can do is you can put a colon here and just call the other constructor. And so what I will do, when this constructor is called, it calls the base constructor first, so this one, and then it calls, it does all this. And you can chain these like in huge change as well. And another thing, we have assigned the name and age here, but you can put those in this list here as well, after the colon here. So you can say name n and age a, and that will actually do the same as this copy, so you can get rid of this. Okay, like this then. So you can say the name is n and the age is a. That's the same as setting them in this body here. And it's actually preferred to do that as well, but for the next stuff, so like that was the basic stuff, and I have a whole list of other things we can do. And I'm just going to put up a vote real quick. So you guys can vote on what we'll do next, and this is not what I intended. So I have this poll here, and you can all just vote on what topic that we'll discuss next about classes. Because there is a whole lot of things to discuss, basically. Right, seems like most people are going for this pointer. So we'll start with that. Basically, we have this class animal again. And we'll write some quick code here. Has an int age and a float good word points. And now we have a function which accepts a pointer to an animal. All right. So what we can do here is, suppose we want to call this function. Suppose we have a function here in the animal class. Like that. Okay, my bad. Okay, there we go. So suppose you have a function that takes an animal pointer and a function inside animal, which is called print or x or whatever. It doesn't actually matter. And in x, we want to call this function here. You could say, okay, we want to call. Yeah, true, you're right. So we want to call function here, but you can't really fill out this parameter, except if you use this pointer. So this, for the people who have ever wrote Python, this is exactly the same as in Python self, except this is a pointer and self is, well, Python doesn't have pointers, so it's not a pointer. So what this will do is we'll call function, and if we just make an animal here and call dog.print, then dog.x, I'm sorry. So if you call dog.x here, then this is a pointer, and it points to an animal, and in this case, it points to this dog. So if you just, in this function, print dog.age, and you can include iostream for that, and say dog.age equals 4. Okay, like that. And if you run this, then you can see it's 4. So basically, we have this dog. We set its age to 4, and we call the x function. And in the x function, we call another function with this. And in this case, this points to this dog here. If that's clear. I hope it is. So for the people who wanted to have an explanation on this, yeah, okay. What exactly are you lost on? That depends. You could make them print both. You could say you could make it print both as well, but this just this function just prints one. I could make them print both. It doesn't actually doesn't really matter. Yeah, so the array, the arrow is exactly the same as the dot, except it's for a pointer. So if I write animal dot age, you can see it doesn't work because this is a pointer. But if I write animal arrow age, then it does work. So the arrow is just the same as a dot, but for a pointer should actually not be like that. But C++ is weird. So and if it doesn't take a pointer, if it just takes a regular animal, that's a good question, because then this is a pointer, but animal is this is not a pointer, so we get an error here. No suitable constructor exists. Blah 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 blah. So how do you change that? You just dereference the pointer with the dereference operator, and now you get a regular animal back. What's that? Variables. The this is pointing to the animal itself. It's not pointing to the age only. But yeah, you can use the this pointer to access the dog, essentially. So wait, so this is pointing to dog, and then the dog has its own variables inside, like age and good boy points and whatever. Yeah. The way you can also see this, maybe that makes it clear, is by adding a hidden this as a parameter to the function. Basically, every member function is translated to this. So you just add the this is the same member function basically, but then how the compiler can see it. So you have the member function, but there's this pointer that you don't see. There you don't have to write it, but the compiler basically adds it, and then the function is called like x dog. That's basically the same as the this pointer. So like it's a parameter to the function, but yeah, the dot accessor is like just accesses members in the class, from the class. So to go from the dog to the age, you use the dot. Yeah. Any more questions about the this pointer, or is that clear? Right, I'm just going to I'll take the next thing in the poll and take a look what's in there. Oh, structs and classes. Yeah, okay. So basically, C++ has another thing to do classes, and it's a struct. I'll just delete this. So you have struct animal, and the good thing is there's not much to remember because this is exactly the same, except with one difference. With a class, you can think that there's private here because everything is private by default in the class. And with a struct, everything is public by default. And that's the only difference between a class and a struct, basically. So if I write a struct animal and have an int age in here, I'll just remove this. I can access this age, animal dog age 4C. I can access this, no problem. If this was a class, I cannot access it because the class has private access by default. Now, why should you use a class over a struct? Basically, what I try to do is I try to use classes for things that have many member functions and are complex things, and structs for stuff that's just a bunch of variables grouped together with no behavior at all. So typically, a struct in my code will not have a member function. So this never, in my code, basically never, but the class will have that. That's how I try to make a difference between the two, basically. A struct is like an interface in Java. Not really, no. A struct is Literally, just for me, it's just a group of a bunch of variables grouped together under a nice name. Use like an interface. But yeah, in C for C++ for the compiler, there's no actual difference. It's just some convention I try to stick to. And how do you access private variables and functions? That's a very good question. An enum is slightly different as well, but we'll get to that in a second. So, question from Bash: how do you access private variables and functions? Well, you can access them inside the class. So, let's say I have this is private, but this is public, and you want to somehow, outside of the class, still get access to this age. Now, what do? There's no way of you to just write simply animal dog.age equals 5. There's no way to do that. Print dog. You cannot do that. But what you can do is you can write a function inside animal to return the age to the user. So just return age. And so what this does, it's just a member function. And remember, member functions can access private members. So you just have int get age, return an age, and then you can call get age here. And that's a way to access private members. I'll just make compiler shut up. So that's a way to access private members. The other way is just inside the class. You can use them as much as you want. And then you can just use an enum too. That's also a question. An enum is something different. For example, fruit or whatever. Because an enum just stores a few values like banana or apple. And those are just plain values. While struct is actually, you can have an int with an age. You can have float with some other data. You can have a string in it. It can do whatever. Why do you need separate members to either? Well, some members you want to be private, like some internal data that the user of your class shouldn't access. Like, let's say a dog's good boy points, an animal good boy points. You don't want to expose this to anyone, because anyone could come around your dog and say, okay, we'll take all this dog's good boy points. You don't want that to happen. Instead, you want a very controlled way of accessing that, like void add good boy points, and it just says this, for example. And now someone cannot just come along and say dog.good boy points. You cannot do that. You can only add to them right now. So that's like a way. Yeah, other access is access from the user. So yeah, to avoid mistakes like accidentally taking away someone's goodwill points. Naming conventions in C++. C++ doesn't actually enforce any naming conventions, but you should take one and stick with it. That's the idea. Just pick one you like, experiment a bit, and then stick with it. Be consistent. That's yeah. A struct can have functions, but I try to avoid it just to make like a difference in intent, basically. Yeah, as a struct does have different. Yeah. Um, so like yeah, this is one of the ways you can use classes and stuff to protect some data. You don't need this private, but so now no one can just come along and say, "Hey, dog, here, good boy points are gone." You can only say dog.add good boy points 5, for example. You can do that. If there are more questions, then feel free to ask. Yeah, that's a good that's a good one actually. You can take all the good points from there. Yeah, I also that there's no enforced naming conventions by the compiler. You just pick one you like and stick with it. Or if you contribute to a project, like say you want to compile, you want to make a pull request to some big compiler or something, you should always read their style guides and use that. Or if you want to like Unreal Engine, you want to make add some code to that, just stick with their guidelines. Makes life a little easier for them. Wait a second. Would I improve using private classes? Yeah, probably because well, you can add extra validation in those classes, and essentially, it's very nice to be able to group code together. Like all this code belongs in one blob of behavior or data, and you just it makes it very easy to debug code and be like, okay, this is a module of code. Basically, this works. Okay. Also, if structures can have functions, why do you use as group of variables? I just started doing that initially because I thought I had to, but then I discovered I don't have to. But I just stuck with it because it makes for a nice distinction in the code. Basically, it's just nice to have. What's next? I'm just going down the list of the poll results. Okay, copy constructors. Yeah. So let's say you have this animal, this dog, and we want to make a copy of this dog. We want to make a second dog. We want to clone it basically. So we say animal. I'll just keep this. Okay, so say we want to make a copy of this dog. How do we do that? We want to say animal another dog equals dog. We want to be able to write this. And right now that works, but if I just add the default constructor, you can see this should not compile. Wait. Okay, there we go. But this is not supposed to compile, I think. Okay, it does. Whatever. So if you want to make a copy of this dog, you want to do some stuff. What do? We write a constructor, and it should take another animal as a parameter. Yeah, there's some rules in C++ with explicitly if you define a constructor. Oh yeah, right. You're right. So if you define like a constructor, then it doesn't automatically define other constructors. We'll get to that in a second, maybe. But let's just first do this. So a copy constructor, it's again a constructor, but it takes a const reference to an animal as parameter, always the same. And in there you can just write good boy points equals animal dot good boy points, and that will make a copy of your animal. What I was talking about earlier, why would that not compile? If I write nothing, you can see that this still compiles, and the reason for that is that the compiler just manually, automatically adds some constructors for you. It adds a default constructor, it adds a copy constructor, it adds a move constructor, and it adds copy and move assignment as well. But if you define some other random constructor, then it doesn't do that. Or it usually doesn't do that, but apparently it does right now. I think I screwed up somewhere, but yeah. Oh, this is the this should be a copy constructor actually. No? Yeah, the default constructor is this one. Basically, it does nothing. But actually, it does do something. If I write goodbye points is 5 here, then this default constructor, yeah, const animal reference, that's the same. Yeah, yeah, that's the same thing. I just prefer to write const on the right because it provide write const to the right of something. Yeah, that's good. Yeah, that's a good table. Very good table. I prefer to write const over here because there's this thing, right? If you there's the general rule, const applies to what's on the left, except if there's nothing there, then it applies to what's on the right. So if I write const int pointer x, then it's a pointer to a const integer. Okay, but if I write int pointer const x, then it's a const pointer to an integer. But it makes for a rule with like exceptions and stuff, so I prefer to just write int const x because it just simplifies the thing of const is always to what's on the left, basically. That's why I put the const over there. That's no Anton influence, that's just me. Good try there. Let me just check. So classes like this, they're pretty nice. You can use them for a lot of things, but there's more. So say we have this animal, right? It has goodbye points and it does some other stuff. And now we want to make a special version of an animal, like an animal with wings. Because an animal with wings not only has goodbye points, it also has, it needs to eat maybe. Like wing animal, there we go. And it should be able to eat. Or whatever, food, whatever, something like that. Makes no sense that a winged animal needs to eat and a regular animal doesn't, but okay, for the sake of the example. Now, if you want to like have all of this stuff in the regular animal, we could just copy paste, of course. There we go, done. But copy pasting code is annoying, as you can see. It also doesn't compile because you have to update the constructors and blah 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 blah. Not very fun. Instead, there's a solution. You can use inheritance, and what that basically does, you write a colon after the class name. You write public because we want public inheritance in this case. There's also private inheritance, but you don't usually use that. And what that does is it will just bring over all the contents of animal into winged animal. So this winged animal class also has good waypoints. It also has add GBP as a function. So we can write winged animal bird and bird.add GBP5, and you can see that actually works. Because this function, we can think that it's basically in here, except it's not, it's in here, but it's brought into the winged animal class by the inheritance. And that's a very, this is actually what Java interfaces are in its core, just lots of inheritance. Yeah, that's really, really useful. Well, Java inheritance, yeah, it's similar. We'll get there. We'll get there. Yeah, okay. Okay. So this inheritance is very, very useful for if you want to like bring over code, but you have to be careful because it also I see many people doing this wrong basically, or using inheritance in wrong places. And what I try to remember use inheritance is that it has an is-a relationship, basically. So a winged animal is an animal, but if I write class block, for example, public animal, because block happens to have the same functions that we need, a block is not an animal, so you're not supposed to write this. Don't do this. Even though you might want code from this animal class inside block for some reason, but a block is not an animal, so inheritance is always wrong. Or let's say you have a better example, class motor or engine, sorry, class engine and class wheel, for example, and you want to make a car, then you could write class car, public engine, public wheel. So a car, it inherits from engine and inherits from wheel because we need the code inside the engine and the wheel to operate the car. The problem with this is a car is not an engine, a car is not a wheel, so don't do this. Instead, you should write something like wheel, and engine. Of course, a car has 4 wheels, so we need 4 wheels, but yeah. So a car has 4 wheels and has 4 engines, but it isn't, so that's not inheritance. That's the right way to do it, basically. And where inheritance gets really powerful is with virtual functions and interfaces. So basically, if I have a class animal again, and I just make a function, bark, no wait, virtual functions, yeah, exactly. I'll explain that right now. Function makes sound for animal, right? I can write cout, yeah, well, nothing really, because just an animal doesn't really make a sound. And then I can write class dog, inherits from animal. And I can try to, and here I want the dog to make a bark sound. So I can write void make sound and cout bark. Let's include iostream for that. And then we can write dog make sound, just like that. And yeah, that works. You can see it prints bark, but the problem with this is no, it's fine, but it's not really great because make sound in animal, it doesn't really have anything you can write there because just an animal can make a sound. But what you can do is make this virtual. And if you make it virtual, there's a very good thing you can do then. Because if I have now an animal, and I assign a dog to that, just like that, this works because a dog is an animal, so I can assign a dog pointer to an animal pointer. That's C++ and inheritance. Basically, you can assign a pointer to a derived class, which is the dog, to a pointer to a base class, which is the animal. So this, even though animal and dog are different pointer types, that actually works. And if I now write animal make sound, then you would think that it would print oof, maybe because it is an animal pointer, right? So because we have an animal pointer and we call make sound on it, so it should go here. But instead, if you print this, it prints bark. And that's polymorphism indeed. So we have an animal pointer, but it points to a dog. And because C++ knows that it points to a dog, it can actually tell the compiler, hey, we should call this make sound, not this one. And especially good is because, well, make sound, this doesn't really make sense. So we can make this a pure virtual function by writing =0 behind that. And basically what this does is it If we now try to make an animal instead of a dog, that doesn't work because object of abstract class type animal is not allowed animal make sense. It's a pure virtual function. We might be able to Alex, but there's no critical performance concerns in the code that the people here are going to write, basically. So this basically prevents you from making an animal, because if you would, calling make sounds, what is change between a virtual function and a normal one? Well, if this would not be virtual, if you can just do this and cout oof, and we try the same as before, the only difference here is virtual. This is virtual, and we get the same results as before, bark. If this is not virtual, then this doesn't work, and we get oof. So because it's not virtual, the compiler doesn't really know what to do with this function, and it just calls the base version of animal. Because it sees an animal pointer and it sees a function that's not virtual, so it calls the animal version of make sounds. But if we make it virtual, then we tell the compiler to look for the correct make sound version, basically, which is in this case bark. But with a pure virtual function, we cannot no longer make an animal now because make sound doesn't exist, and now animal is exactly the same as a Java interface. Basically, you have this function, and the derived class has to implement it. In this case, with bark. Make another class like cat, and it can have make sound as well, like this, and you can print meow or whatever. And now we can assign a cat to that, and the same thing works. Now let's say you have a special dog, like a Labrador or whatever. It should be recorded, yeah. So we can now make a Labrador inherit from dog. And I misspelled that. Yeah, virtual function, how are they beneficial? Does that require the override keyword? It doesn't, but it makes things a little more explicit. You can put override there, but you don't have to. I try to do it as much as I can if I use this to make things a little more clear. But why is virtual good exactly? Well, you could any user of animal has to implement this make sound function. So that way you can just get around a bunch of animals in some vector, like say I make an array of animals, vector, or just fixed size array, maybe animals, a bunch of animals. We can call that the zoo if you want. And if you want the whole zoo to make sounds, we just go over each animal in the zoo, and we say. So what this allows you to do is it allows you to store different objects, because you can store a dog and a Labrador and a cat and a cow all in the same array of animals. And that's a really neat thing because, well, you can have different specializations of the same stuff inside one array, and that's one of the advantages of this virtual stuff. If that's clear. All right, cool. Anyway, so back to this. If you have a Labrador, then inherit from dog, you can override make sound again. For make. This is the second. You can override make sound again, and make it output Park Labrador, for example. And that does something else then. So you can have these long chains of inheritance all going down however far you want. And yeah, there's some very powerful stuff you can do with it. The problem is that it becomes a little messy sometimes when you have like tons of inheritance everywhere. You have to look into different classes, like where does this go? Where did this is this function implemented and stuff? But overall, it's a pretty good tool to use for some stuff. Let me just check if there's a new topic we can try. Are there any more questions about inheritance, actually? Let me just check that first. Well, this is the basic of inheritance. There's more. Yeah, regular virtual functions. The difference is that you can have a base version to fall back on if you have an actual animal. Tell me where I disconnected because I don't actually know where my explanation.
Abstract virtual functions.
Shit, that's soon. Okay.
Yeah, go ahead, dude.
All right. So we were doing this, I think, these abstract virtual functions. Is it not shared?
It's paused because you're sharing Discord, I think.
Oh, wait. Yeah, I have no permission to stream for some reason. Oh wait, no, I do. Never mind. I do. Yeah. Okay. So I think we were talking about differences between abstract and non-abstract virtual functions, and basically the idea is that if you want to make implementing the virtual function optional, like this, you use regular virtual functions. So you can have like a default implementation that just outputs like sound or whatever sound. And if you want to force the user to implement the virtual function, you make it abstract. That's basically the difference. And then I started talking about nested classes, but that didn't go through apparently. I disconnected there. So basically, say you have this class zoo, and inside the zoo you want to have class animal. You just type that here. You can just nest classes as much as you want. You can have another class inside that. food or whatever. And you can just keep going. You can have structs inside there. You can have enums inside there. You can have a union inside. But yeah, so you can just put classes inside classes, inside classes, inside classes, and so on and so on. Wait. I don't remember what we have next. If it wants to load. Namespaces. Wait. Something's weird. Okay, so if you want to access this this class animal inside of the zoo class, you just write zoo : animal dog, and then it takes this class from inside this class and makes a dog of that type. So you can do this with structs. You can do this with an enum and whatever. Let me see. All right, so two final things we can discuss. First of all, we have friend functions and friend classes. So suppose I have a class zoo and a class animal somewhere. Or even better, maybe animal and a class zookeeper. So we have our animal dog and our zookeeper. And basically, our animal has a private member, as we remember. Scope resolution after this. Wait. So we have our animal with our good boy points, but it's private. For our zookeeper, we want to give the zookeeper access to the good boy points because we trust the zookeeper. He can do with the animal whatever he wants. So what do? We say inside the, sorry, no, it can be like this. Yeah. So inside the animal class, no, it's actually scope resolution operator, but okay. Inside the animal class, we can say friend class zookeeper. And what that will do is it will tell the compiler the zookeeper class is a friend of animal. That means that zookeeper can access the private members of the animal. So if we inside zookeeper write the void function, we can say it takes animal. We can say animal good boy points equals 5. And the zookeeper can access the animal's private stuff. So in C++, friends can access your private parts as you can say that as a joke if you want. But yeah, so if you trust, yeah, so if you trust the class or you need that specific class to access some private members, you can use friends. And the same thing can be said for functions. So a print function that needs to print. No, animal cannot access zookeeper field, so it doesn't work backwards. So if the zookeeper would have a private member, then the animal cannot access it unless you declare animal as a friend of zookeeper. But suppose, yeah, one-way friendship. So what's the usage? Let's say you have some internal data members or something that you don't want anyone to modify, but you have some class that works on these, like zookeeper, and it does need access. Then you can use friends. You don't really need it often, but sometimes it's quite useful. And another thing is friend functions, which is basically the same except for functions. So let's say I have a function print, right? And we want it to print an animal like that. So we want to print the dog. Wait. So we want to do this, for example. That won't work because print is not a friend of animal, but we can do friend void print animal. So we just add the friend keyword and then the signature of this function. Is it lagging? I don't know. And then you can access the private stuff. So you have friend functions and friend classes, and they can access the private stuff in their implementations. So why would you use inheritance if you can use friend functions? Well, inheritance is just something different, right? Friend functions is all about accessing private stuff, or yeah, friends are all about accessing private stuff, and inheritance is about saying, okay, we have an animal and we have a specialized version of the animal, which is a dog. One thing now that we have touched on inheritance that we can now take a look at is protected. So we said all the way at the beginning of the stream, we said we have public and private as access specifiers. But there's a third one, protected. And yeah, so all the way at the beginning, we talked about public and private. But there's a third thing, and that's protected. And basically, protected is the same as private. In one way, that outside of this class, I cannot access age. See, it's inaccessible. But if I make a class inherit from animal, like this, in here I can access age. So protected basically means private except for derived classes. So outside animal, we cannot access age, but inside dog, we can access age because it inherits from animal. Yeah, friend doesn't make it inherited or anything. It just allows access to all the private stuff you want. So inside here, yeah, you could write. So this age or even animal, this works too, but that's not really necessary. You can just write age as well, and that will take this age and assign for it with. After class virtual class and interface. An interface in C++ doesn't really exist, and it's the same as an abstract class basically. And a virtual class is something different that doesn't. Well, you didn't call it like that, but suppose you have a device and a class. Oh wait, a class printer and a class scanner, right? And we make a printer. Wait, I have to think about this. Yeah, and we have a class device. So I have a device, and a printer is a device, and a public scanner is a device, and a printer scanner is a printer, but it's also a scanner. And now in here, in the device, we will add a name. Like that. And there's a big problem with this. Because as you can see, the printer has a copy of name, the scanner has a copy of name, and the printer scanner has a copy of printer and scanner. So if we write a function in here, and we try to access name, say name equals blah blah blah, then it starts to give errors saying, just take a look, name is ambiguous because you cannot know if it's the name that comes from scanner or the name that comes from printer. And this problem has a name. It's called a diamond problem, and there's a reason for that. If you just open Paint real quick, so we have our device and printer and scanner, and our printer scanner, and we can just draw the inheritance here basically by saying, wait. So a device is a printer. Yeah, basically that. A scanner is a printer. A scanner is a device, and this. And you get this kind of weird diamond shape because I kind of draw. But the idea is that printer scanner has 2 copies of device, which is a problem. And you can solve this by just doing what's called virtual inheritance. So basically, you add virtual in front of these. And that will just tell the compiler to, wait, no, not here. Yeah, I'm done. You inherit from, the virtual inheritance from device here, and that will basically tell the compiler, okay, just figure it out. If somehow 2 copies of device end up in one class, you just pick one and assume it works. That's basically what happens, and that solves this problem basically. Try to avoid this. Try to avoid virtual inheritance because it's kind of a hack and a little bit ugly, but sometimes you need it. So it's good to know about it. Because otherwise you can be stuck on that problem for a very long time if you don't know what this means. No, it's not really random. The compiler will just remove one device basically. So if you do this, it'll just say, okay, I have 2 devices, but I'll just say this device, we ignore it, and we only end up with 1 device in the base class basically. So it's not really random. Yeah, that's so if we do not do virtual inheritance here, yeah, the device is the same, so it doesn't actually matter which one it picks. That's why it's fine. You can see the name is ambiguous because it can come from this device or from this device. But with virtual inheritance, you just say pick one and we'll be fine. And there's one final thing I wanted to quickly touch on. Yeah, you can do that. You can say printer name, but then without virtual inheritance, you can say the printer name is this, but the scanner is that. You can do that as well. But usually you don't need this. Usually you just mean to have one device and you by accident included it twice. But yeah, that solves this issue as well. There's one final thing I wanted to quickly discuss. Say you have some class. You have an animal. And we have a name, of course, in there, whatever. But we want to somehow, see, how do I say this? We want to have some number of animals, like a total number of animals. Should I represent mathematical functions using object-oriented programming? No, you should not. Mathematical functions are not objects. You cannot just say this is an addition, for example. Like a class addition just makes no sense, really. Don't do this. Yeah, a vector too, but that's not a function. That's just a mathematical type. But yeah, vector 2, stuff like that. Why does it create a vector? Yeah. Why does my lecture create a linked list with structs and not classes? No idea. Yeah, so Alex is right. Object-oriented programming can be good, but just regular functions are just fine as well. Don't start slapping a class on everything because you think it's good. Just sometimes you just want a function, and you don't need to force yourself into like making it a class because you learned about classes now. Sometimes a function is just better. But I think we had pure virtual versus virtual, but okay. Yeah, pure virtual functions. You can add const if you want. You don't have to. Pure virtual functions can have a body too. What? Really? Is that a thing? Oh, Alex, you sneaky bastard. That's not a body. Wait, no. I actually don't know. Alex, what did you just do? Why did you... No. Okay, I don't accept this. Don't listen to that man. So one final thing I wanted to say is you can have static... you can have one other type of member in an animal, in a class, like this. And what it basically does is it makes, if you just make an animal, for example, so if you just make an animal here, we cannot say dog dot total amount of animals. Actually, we can, but whatever. That's not what you're supposed to do. So total amount of animals is basically some variable that is shared by all animals. Yeah, okay, whatever. So this variable is shared by every single animal. So if I have a second animal, a cat, and I say dog, total amount of animals equals 5, and then I see out cat, total amount of animals. I'll just remove this. And if you compile this, what is this? Oh yeah, okay. Yeah, so why doesn't it let me initialize that? Basically, C++ is weird, and if I initialize this variable, it says that a member with an in-class initializer must be const. So I have to make this const if I want to put it inside the class, the initializer. If I don't want to make it const, I have to declare it outside the class as well, like this. Something like that. But yeah, so this variable total amount of animals is shared by every single animal. So this cat animals, if you just run this, you can see it's 5. Even though we only set the animals of dog to 5, we can access the same variable like that. And if you want, you can also use animal like this and animal, and it makes it a little more clear how this works, because total amount of animals is basically a variable that belongs to all objects of animal. If there's any more questions, feel free to ask right now. And I think that's about what I was going to say today. So yeah. Thanks. My beautiful diagram. I'll just end the stream.